Good morning. I hope everyone is having a good day. I'm Sheila May Reyes, one of PAGASA's forecasters, and I will be talking about tropical cyclone forecasting and warning during pandemic. This will be the outline of my presentation. First, an overview of the timeline of the tropical cyclone forecast process in PAGASA, then the tropical cyclone operations. We will have a quick review of the tropical cyclones within the Philippine area of responsibility in 2020 season, the challenges that we've encountered during the pandemic, lastly, the opportunities for improvement in tropical cyclone forecasting. This is the overview of the forecast process, just to give you an idea of what we do during the 3-hour time period. We usually work on 6-hourly forecast cycle, but if the tropical cyclone is forecast to make landfall in the next 24 hours, or the tropical cyclone is over the landmass or within 100 kilometers from the landmass, we do 3-hourly forecast cycle so that we can update the severe weather bulletin every 3 hours. Mind you, this is the ideal timeline. There are instances that we don't follow this timeline or we go beyond the set time for some certain reasons. The first R is setting the stage. For example, if we start our analysis at 8 a.m., so from 8 to 9 a.m., this is the time where the typhoon forecaster conducts tropical cyclone analysis. First, the center fixes. For example, the satellite center fix, radar. If the tropical cyclone is over the landmass and no available radar data, then we look on the synoptic observations and other available data. Then the forecaster will decide for the initial location, that is the center of the tropical cyclone. Then he or she can compute for the initial motion as well as the direction. The current intensity is analyzed, then the tropical cyclone size. Also, during this time, we start receiving some data for the track and intensity model guidance. The next R, that is 9 to 10 a.m., is creating the forecast track and intensity. So when the forecast track and intensity are finished, we will identify the areas under tropical cyclone wind signal. The last 1 hour, that is 10 to 11 a.m., is intended for formulating the severe weather bulletin and tropical cyclone warning for shipping. Forecast coordination is happening also during this time. As you can see, the products are issued every 3 hours after the analysis time. Tropical cyclone operations is an end-to-end process that covers analysis, tropical cyclone forecast, provision of warnings, and verification. In Weather Division, tropical cyclone operations are handled by a duty typhoon forecaster and supervisory typhoon forecaster working in a 12-hour shift. However, all the weather and marine forecasters are involved in the formulation of the warning and advisories. Before we go into detail about the tropical cyclone operations, this is the work setup of the forecasters during the pandemic. The Weather Division continues its services 24/7 despite of the pandemic. We implemented skeletal workforce. Before there are 3 shifts, but during the pandemic, it became 12-hour shift with at least 1 forecaster on physical duty and the rest are scheduled working remotely. And during the tropical cyclone events, especially a landfalling tropical cyclone, forecasters that are assigned work from home are advised to render physical duty. For tropical cyclone analysis, so for the intensity, we use the Dvorak analysis. So we have satellite meteorologists providing us this analysis. We also use the objective intensity estimates like SATCON and ADT, ASCAT for center fix as well as for determining the wind radius, radar and microwave imagery for the center fix as well as for tropical cyclone structure. And we still do hand analysis, isobaric analysis in the surface and auxiliary maps, and streamlines in our upper air maps. This is the comprehensive list of the tools that we use in our tropical cyclone analysis. I will not go into detail, but I just want to emphasize again that we usually do a 6-hourly cycle analysis. But if we have a landfalling tropical cyclones, we do 3-hourly analysis. So the additional analysis time would be 03, 09, 15, and 21 UTC. So in local time, 11 a.m., 5 p.m., 11 p.m., and 5 a.m. For tropical cyclone track and intensity forecast, in our track forecast, we use what is available in the NTP website of RSMC Tokyo. We refer also to the model aids of JTWC, and we use also the WRF from PAGASA's NMS. For the intensity forecast, the intensity guidance from GMA, which is available in the NTP website. Intensity guidance is also available in the JTWC Collab website, and we also use HWRF. These are the products that we issue to the public: the track and intensity forecast, the tropical cyclone wind signal, severe weather bulletin. This is just a portion of our severe weather bulletin where we explain the outlook of the track and intensity and the hazards associated with the tropical cyclone. Then the tropical cyclone warning for shipping. As you can see in this product, you can obtain the initial position, the forecast positions, maximum wind, pressure, movement, and we also provide for the wind radii of 30, 50, and 64 knots in every quadrant. And lastly, storm surge watch and warning provided by the HTMERS. After a tropical cyclone event, we do reanalysis and verification. So in this example, we compute for the track error. PAGASA don't issue warnings for the whole Western North Pacific. We have 3 domains to consider to trigger issuance of tropical cyclone information and warnings. And each domain has a specific warning products or information that PAGASA provided to the public. For example, if we monitor a tropical cyclone over the advisory domain and it is forecast that this tropical cyclone will enter the PAR in the next 5 days, then we issue a tropical cyclone advisory, and that advisory is issued every 11 a.m. Once it enters the PAR, that is when we issue a severe weather bulletin. This is the summary of the warning products that we issue and the time of issuance. We issue this product after 3 hours of the time of the analysis. When a tropical cyclone poses a direct threat in terms of damaging or destructive winds on one of the localities in the Philippines, PAGASA issues a tropical cyclone wind signal over the area depending on the intensity and the expected arrival of the tropical cyclone winds. So signal number 1 as the lowest and signal number 5 as the highest. And each number has corresponding expected strength of the winds, lead time, and impacts. Just a review of the tropical cyclones in 2020 season. These are the tropical cyclones that are observed within the Philippine area of responsibility. A total of 22 tropical cyclones formed within or entered the PAR. The red tracks are the landfalling tropical cyclones, and the blue tracks are non-landfalling. The black circles refer to the time PAGASA first noted it as tropical depression. So you can see roughly 81% of the tropical cyclones formed within the Philippine area of responsibility. 12 tropical cyclones made landfall over the Philippine archipelago, while 10 tropical cyclones are non-landfalling. First tropical cyclone event happened on May, that was Typhoon Ambo. 3 tropical cyclones made landfall as typhoon intensity, and 1 tropical cyclone as super typhoon. So Raleigh made landfall as super typhoon with maximum sustained winds of 120 knots and central pressure of 915 hectopascal. I think these are the main challenges that we've encountered during the pandemic. First is the model accuracy. The models had been struggling last year. Maybe one of the contributing factor is the reduction in flight level data. Second, technical problems. Because most of the time we are working remotely, we often encounter this dilemma of having a slow internet connection that leads to slow response of the remote desktop that we are using. And this difficulty affects the time of issuance of the products. So there are times that the products were issued late. Third, the lack of manpower, especially during tropical cyclone event. Even though we required the forecaster working from home to report in the office, but still we are overwhelmed by the number of phone calls and media interviews. And this usually happens during a landfalling tropical cyclone, especially when Metro Manila is affected. Not unlike before that we have the support group not unlike before the pandemic that we have the support group from other divisions. These are the opportunities for improvement in tropical cyclone forecasting. Actually, there are many opportunities, but I listed three that I think the highest priority in terms of track and intensity forecasting. The last two are more on information delivery and public awareness. First is the guidance for tropical cyclone intensity change, especially in rapid intensification and weakening events. As a forecaster, you need to know the onset of that event, the duration, and the magnitude when this event happened. Second, though track forecasting has improved steadily for the past 3 decades, but there are still room for improvement, especially to reduce the large speed error. This happened on recurving and quasi-stationary tropical cyclones, and to reduce the direction errors. This usually happen on looping tropical cyclones. Third, operational analysis and forecasts on the surface wind field of tropical cyclones. Fourth, to boost effective hazard information and public awareness. Because up until this time, we hear complaints that we didn't forecast for a certain heavy rainfall event, though we already indicate a likelihood of this event in one of our bulletins, or sometimes they did not understand the forecast information or its implication. Time to time, we forecasters also assess ourselves if we have really conveyed the risk to the public appropriately. So I think it is really important that the public are aware of this hazard and its impact, or to foster a sense of ownership that when they hear and read warnings, they will recognize the possible impact and will take action. So I think impact-based forecasting would really be a big help for this. That ends my presentation. Thank you for your attention.